We've seen Tom Holland's Spider-Man join forces with other Spider-Men from the multiverse. We've come to see Loki fly through seemingly infinite versions of himself, and the same goes for Doctor Strange in his multiverse of madness. But could this really exist in real life? Infinite copies of yourselves, your surroundings, and the actual entire universe in itself, all with a slight random variation. Dr. Stephan Hawking pondered about this possibility for decades, eventually revealing his final theory in 2017 before his death. We now might just be ever closer to proving that an infinite number of you and I's could exist. How is this possible? Let's find out. The James Webb Telescope is designed to look back in time, searching the universe to find out what happened before the Big Bang and giving us new insights into the origins of the universe. After years of searching, it has finally found something that is changing everything we knew about the universe. Let's get some basics out of the way. It is estimated that the universe is 14 billion years old. Everything we see today was created by the Big Bang. The universe continued to expand after the Big Bang. The stars and galaxies formed over time. Our Sun is one of the billions of stars in our own Milky Way galaxy. The Sun is the center of the solar system, no surprises there, and the solar system revolves around the Sun at an average distance of 93 million miles or 150 million kilometers. For decades, scientists have been looking for an explanation as to how life came about. Our universe is just one of many, separated by an infinite expanse, as proposed by Stephan Hawking in the 1960s. After searching for evidence of other universes for years, scientists may have found it with the James Webb Telescope. The telescope has been able to see other universes by using gravitational waves. These other universes are expanding faster than ours. This implies that we live in a bubble universe where there are multiple Big Bangs taking place, according to lead researcher Ranga Ramchari from Texas A&M University. There are more than 100 different types of universe out there. We could be a part of this great cosmic environment. But does this mean the multiverse really exists, you ask? Well, Professor Stephan Hawking's final theory on the origin of the universe, which he worked on in collaboration with Professor Tom Hertog from KU Leuven, was published in 2018 in the Journal of High Energy Physics. The theory of the multiverse is tightly tied in with his theory, submitted for publication before Hawking's death in 2018. This theory is based on string theory and says that the universe is finite and much simpler than current theories about the Big Bang say. Professor Hertog, who has been funded by the European Research Council, first announced the new theory at a conference at the University of Cambridge in July 2017. This conference was held to celebrate Professor Hawking's 75th birthday. Some modern ideas about the Big Bang say that our local universe came into being with a quick burst of inflation just after the Big Bang itself. In other words, right after the Big Bang, the universe grew quickly. It is thought that there are regions where inflation never stops once it starts, and quantum effects can keep inflation going forever in some regions of the universe, so that globally, inflation is eternal. The observable part of our universe would then be just a hospitable pocket universe, a region in which inflation has ended and stars and galaxies formed. Professor Hawking said in an interview from 2017, "The usual theory of eternal inflation predicts that globally our universe is like an infinite fractal with a mosaic of different pocket universes separated by an inflating ocean. The local laws of physics and chemistry can differ from one pocket universe to another, which together would form a multiverse. But I have never been a fan of the multiverse. If the scale of different universes in the multiverse is large or infinite, the theory can't be tested." In their paper, Hawking and Hertog say this account of eternal inflation as a theory of the Big Bang is wrong. Professor Hertog explains, The problem with the usual account of eternal inflation is that it assumes an existing background universe that evolves according to Einstein's theory of general relativity and treats the quantum effects as small fluctuations around this. However, the dynamics of eternal inflation wipes out the separation between classical and quantum physics. As a consequence, Einstein's theory breaks down in eternal inflation. Professor Hawking also reveals, we predict that our universe on the largest scales is reasonably smooth and globally finite, so it is not a fractal structure. So wait, what's this eternal inflation theory now? Professors Hawking and Hertog's theory of eternal inflation is based on string theory, which tries to combine gravity, general relativity, and quantum physics by describing the smallest parts of the universe as tiny strings that vibrate. Eternal inflation is a hypothetical inflationary universe model, which is itself an outgrown or extension of the Big Bang Theory. According to eternal inflation, the inflationary phase of the universe's expansion lasts forever throughout most of the universe. Because the regions expand exponentially rapidly, most of the volume of the universe at any given time is inflating. Eternal inflation therefore produces a hypothetically infinite multiverse, in which only an insignificant fractal volume ends inflation. Their approach uses the idea of holography from string theory, which says that the universe is a large and complex hologram. This means that certain 3D spaces can mathematically be reduced to 2D projections on a surface. To project out the time dimensions in eternal inflation, Hawking and Hertog developed a variation of the concept of holography. Holography is a technique that enables a wavefront to be recorded and later reconstructed. Holography is best known as a method of generating three-dimensional images, but it also has a wide range of other applications. In principle, it is possible to make a hologram for any type of wave. This allowed them to describe eternal inflation without having to use Einstein's theory. The new theory says that eternal inflation is reduced to a timeless state at the beginning of time. Professor Hertog further explains, when we trace the evolution of our universe backwards in time, at some point we arrive at the threshold of eternal inflation, where our familiar notion of time ceases to have any meaning. Hawking's earlier no-boundary theory said that if you go back in time to the beginning of the universe would shrink and close off like a sphere. But this new theory is different from the earlier work. Professor Hertog mentioned, now we're saying that there is a boundary in our past. They used their new theory to make more reliable predictions about the global structure of the universe and predicted that the universe that emerges from eternal inflation in the past boundary is finite and much simpler than the infinite fractal structure that the old theory of eternal inflation predicted. Their results, if confirmed by further work, would have far-reaching implications for the multiverse paradigm. Professor Hawking revealed, we are not down to a single unique universe, but our findings imply a significant reduction of the multiverse to a much smaller range of possible universes. This makes the theory more accurate and able to be tested. Hertog will study the implications of the new theory on smaller scales, which are within our reach of space telescopes. He believes primordial waves, ripples in space-time, generated at the exit from eternal inflation are the most promising smoking gun to test the model. Since the beginning of our universe, these gravitational waves have gotten very big, so they would have very long wavelengths and would be outside the range of the current LIGO detectors. LIGO is short for Laser Interferometer Gravitational Wave Observatory, which is a large-scale physics experiment and observatory designed to detect cosmic gravitational waves and to develop gravitational wave observations as an astronomical tool. There is a possibility that the waves could be heard by the planned European Space-Based Gravitational Wave Observatory, LISA, or seen in future experiments measuring the cosmic microwave background. But what did the James Webb Telescope find? Moving on to more recent times, scientists were able to begin searching for evidence of the existence of the multiverse theory. The recent images of the James Webb Telescope may have aided in proving Stephan Hawking's theory correct. Scientists have found a strong signal from an infrared galaxy known as MAX 1149JD1, a signal which they believe may have come from a primordial gravitational wave, meaning it came from an event so long ago or at such a large distance that light has not reached us yet. This could be evidence of a universe that is almost exactly like our own, but with one key difference: it's much older. Although there are doubts that don't immediately confirm that there are an infinite number of universes out there, this one could be the first we found. Anthony Aguirre, a physicist at the University of California in Santa Cruz, believes this could prove that there may be many histories of the world coexisting. It would mean that all possibilities exist. There could be an endless number of planets with water and life, or none at all. Stars and galaxies, or none at all. Even possibilities where humans never existed. A large portion of the scientific community may not agree with these findings, and until we have solid evidence to prove this, the theory will still remain a theory. But with time, Professor Hawking's final theory will have substance and proof. For now though, the James Webb Telescope is doing its job, and there will be innumerous discoveries coming our way. So what do you think? Does the multiverse theory actually exist? Or did we just find an anomaly? Let us know in the comments below, and as always, thanks for watching Space Age.